and welcome to my room, where today I will be giving you a physical description of an electric guitar in operation. A guitar is a stringed musical instrument which allows us to control the mass, tension, and length of a guitar string to produce specific standing waves along the strings. The vibration of these strings then produces sound waves. An electric guitar, more specifically, does this by converting the vibration on metallic strings into an electrical signal which can then be amplified to power speakers, which will then produce the sounds. To understand how exactly a guitar works, we need to understand a couple physical phenomena, one of which is the phenomenon of standing waves on a string. We have a formula which describes the natural frequencies at which a string of a specific tension, length, and mass per unit length would like to vibrate. So, if n is an integer number, so 1, 2, 3, multiples of this will be the natural frequencies at which a string would like to vibrate. As the tension increases, this whole fraction increases, and the frequency will increase. As the mass per unit length increases, this whole fraction here will actually decrease and give you a smaller frequency. As the length increases, this fraction decreases and creates lower resonant frequency. Another important physical concept to understand is that of magnetic induction. If we have a coil in a magnetic field, we can induce a current in the coil by moving the magnet, creating that magnetic field. If we oscillate the magnet up and down, this current will continuously change direction at the same frequency as that of the oscillation of the magnet. Electric guitars are used to make music by combining different frequencies and ordering them in specific ways that creates noise which is appealing to humans when it is perceived as sound. This is done, as mentioned, by combining several strings and producing several standing waves at the same time, for example, which is what's known as a chord to musicians, or sequencing them in specific patterns to produce melody. Operating a guitar is as simple as choosing which mass per unit length string we'd like to use, adjusting the tension in the string using these tuning keys, and then changing the length of the string by fretting it at a specific point. Pluck the string with our fingers or with a pick to allow the string to vibrate in its natural frequencies. If we didn't want to hear the fundamental and only want to hear the second harmonic, we can dampen the string at the node of the second harmonic. This doesn't allow the fundamental frequency to play because our finger is dampening it right where it should be moving the most. The second harmonic, however, is free to play by itself. Listen to the difference. There are four major steps in the operation of a guitar. The first of which comes in the standing waves on the strings, where we choose the length, tension, and mass per unit length of the string to produce specific standing waves on the strings. The second comes in the pickups. These little circles actually magnetize the strings so that when they move up and down above the coils in the pickups, they actually induce a current in the coils, which leaves the guitar through this wire. This wire heads to the amplifier, which leads to our third step, where the amplifier adds effects to the signal, distorts it, and makes it much more powerful so that it can power speakers. This much more powerful signal now heads to the speakers, where reverse induction, so the opposite of what we saw in the pickups, occurs to drive the speakers back and forth and create sound waves out of the current that's leaving the amplifier. And this sums up how a guitar, through standing waves, induction, amplification, and then reverse induction, produces music and sound. I hope you learned a lot about how stringed instruments work, and hopefully, if you're a guitarist, you'll appreciate the instrument a lot more now.